Welcome to the Unit 4 remediation guided practice. It says define the following terms. The s orbital. The s orbital is a spherical orbital that can contain two electrons. The p orbital is a dumbbell shaped orbital that can contain six electrons. The d orbital is dumbbell shaped that can contain 10 electron. The off-ball principle. The off-ball principle is the filling order, meaning that electrons fill from the lowest energy to the highest energy. The Hund Rule. Hund Rule tells us that each suborbital is going to receive one electron before it receives two. And then the Pauli exclusion principle tells us that no two electrons can have the same quantum number, or basically saying that no two electrons will have the same spin in the same orbital. A photon is a particle of light. Frequency, the frequency is the number of waves per second. And then our wavelength is the distance between two identical points on a wave. Looking at ground state and excited state electrons, it says how can you represent the excited state of an atom in nuclear symbol notation. So if we look at a hydrogen, we'll say that it's hydrogen 1. If we put a star out beside it, we say that it's in an excited state. What happens to move an atom from a ground state to excited state? It has to absorb some type of energy. Which of the substances below are in an excited state? We see that that sulfur atom is in an excited state. The next one, it says draw a model of the for the atoms below in their ground and excited state. So hydrogen, we would just have one proton in the nucleus, one electron shell, and then one electron in that first energy level. In an excited state, nucleus, first shell, second shell, and that electron would just be shown in the second shell. A stable sulfur anion, the only trick here, it's anion, so therefore it is a negatively charged particle, and it's stable, so therefore we are looking that it has a full octet. Stability means it has a full octet. So go ahead and try to draw those. And then lastly, with neon, what we should see is our energy levels, and then we should see our 2 here, and then 8 around it because neon is stable, so 8 around here. I guess that's 8. Make sure we pay attention and try B on our own. Spectroscopy, it says differentiate between absorption and emission spectroscopy. An absorption spectroscopy is when light is absorbed, so it shows all the wavelengths of light except the light that's absorbed. And the emission spectroscopy is just the light that is emitted after something is absorbed. It says describe what light is. Be complete as possible. Light is both a particle, meaning a photon, and a wave. We call that the wave-particle duality. Number 7, it describes the wave below. So go ahead and look in your notes and look up each one of these and just describe what they are. Like I'll give you, for instance, on a radio wave is a very weak wave, very, very long wavelength. So long wavelength, very low in energy. It's used to transmit information. And so that's a radio wave. So go ahead and do that for infrared and ultraviolet. Looking at light calculations, let's do a couple of these. So light calculations, it says calculate the energy of a single photon, and it gives us the frequency. We're using the equation energy equals Planck's constant times frequency. And so all we do here, it's of a single photon, so it's just multiplied. This energy here is multiplied by 1. We can put the integer in here and just put a 1 there. You can add that to the equation, or you can do it afterwards. But we have 5.6 times 10 to the negative 14th, so all we would have is 5.6 E14 times 6.63 E negative 34. 4. Now I'm saying E because we should be using our calculator, and if we have a TI-84, it should be second comma, or if we have another type of calculator, scientific calculator, you need to be using the function and don't do the times 10 and raise it to the caret sign or whatever. Make sure you're using that E. Now, looking the answer we should get, let's give the answer. The answer we should get should be right around 3.71 times 10 to the negative 19th joules of energy. On B, the only difference here, we're going to use the same equation, except there's 10,000 photons. So the equation is now going to look like E equals the 10,000, which would be the N, times Planck's constant times frequency. Plugging all those numbers in, and we should get an answer of right around 5.24 times 10 to the negative 13th joules. And then lastly, looking at this one, see if we can figure this one out. I'll give you a couple hints. It gives us the frequency, but it says it gives us the energy here. So let's go ahead and try to think, well, find the energy and then maybe divide the energy out to find the number of photons, because you're trying to find that N value. Oop, don't want to do that. So moving on to number 9, it says solve for an unknown using the speed of light. So we're using equation C equals, that's the speed of light, equals the wavelength, which we represent like that, and times our frequency. So it says calculate the wavelength of a 1.2 times 10 to the negative 13th hertz photon. So to solve for this, we'll have wavelength equals speed of light all divided by our frequency. So speed of light is a constant, 3.0 times 10 to the 8th, and our frequency is 1.2 times 10 to the 13th. Remember, those should be E's in your calculator. And we get 2.5 times 10. We'll put that E there, negative 5. And remember that E times 10 is the same thing. So on the next one, it says calculate the frequency. So all we're doing is calculating frequency now. So all it is frequency equals the speed of light divided by the wavelength. So 3.0 times 10 to the 8th, all divided by, and since this is in nanometers, just put 580, and then your calculator just go times 10 to the negative 9th, and you should go ahead and get a frequency of right around 5.17 times 10 to the 14th. And then go ahead and try C on your own. So you're calculating the wavelength of a photon with the energy of this. So you're gonna have to use both of your equations there and see if you can't figure that one out. Looking at the octet rule, it says, what does octet mean? Octet means 8. Gotta have 8. 8 is stable. It says draw the Lewis dot diagram for a stable form of sulfur. So it's sulfur with 8 dots around it. Bromine, it's stable. Guess what? 8 dots around it. Oxygen, it's stable. 8 dots around it, and that's what the octet rule means. Means that an atom has 8 valence electrons. So on our periodic table, it says label the following and state how many electrons each orbital can hold. So when we're looking at the s orbital, it is right. Oh, let me change it to my highlighter. It is right here, and it can only hold 2 electrons. Looking at our P is here, and I did not include helium in this because helium is included in s block or s orbital, and if in the p orbital it can hold 6 electrons, and you can see that how many here in s, 2, how many here in, how many blocks here in p, 6, and then you have your d, which is here. How many blocks does it have? 10, so it can hold 10 electrons. And then lastly we have our f block, which can hold 14. Good job. So next it says draw an electron energy diagram for the atoms below. We have nitrogen. Now, an electron energy level diagram is just drawing with the arrow. So nitrogen has 7 electrons. Its electron configuration is 1s2, 2s2, and then 2p3. We represent this with arrows. So 1s, we show an arrow up, an arrow down. 2s, arrow up, arrow down. The arrows represent the number of electrons. So in P, we go to P, it has 3 suborbitals, and then there's 1, 2, 3 electrons. Oxygen has 8 electrons, so we would go 1s, 1, 2, 2s, 1, 2, 2p, 3 suborbitals, and we go 1, 2, 3, 4. Okay, for a total of 8 electrons. Go ahead and try sodium on your own. 14, it says write the electron configuration for the elements below. We're just using our periodic table to kind of map those out. And remember, they all follow the same order. So it all starts with 1s. And nitrogen has 7 electrons, so 1s2. Now we're down to 5. 2s2. Now we're down to 3. 2p, we only have 3 left, and they can all fit in 3, so 2p3. Oxygen, we would say that it has 8, so it's 1s2. 2s2, that took care of 4, and then 2p4. Okay, and that's why we wrote that one out with 8 arrows, because it had 8 electrons, and we see that we wrote it out basically the same way. Try sodium on your own. And then lastly, it says identify the element based on the information below. We have 10 protons, so we know that we are dealing with neon. We have 12 neutrons, so that means we're dealing with 10 plus 12 is 22, so neon 22, and we see that it has our He represents 2 electrons, plus 2 is 4, plus 6 is 10, so 10 protons, 10 electrons, it has the same charge would just be 0, and so we're dealing with neon 22 with no charge.